Dear students, a very good morning to all of you. Today we discuss about electric field due to a dipole. In previous video we talk about what is electric dipole, what is dipole moment, and classification of molecules. That is two types of molecules, polar and non-polars. Electric field which can be produced by dipole. Now when a dipole make electric field, there may be different positions. How this is? We have two type of positions. First is one axial positions and other is one equatorial positions. First we discuss about axial positions. Let us where we have minus q charge and plus q charge and separated by a distance 2a. Such an arrangement is called electric dipole. The center of the dipole is known as dipole center, and which is point O. From point O to minus q, that distance is a, and O to plus q, that distance is a. We find out electric field on the axis of dipole. So let us assume P is a point on the axis of a dipole. We find out what is electric field intensity at point P. Now let us suppose E1 is the electric field intensity at P due to charge minus Q, and E2 is the electric field intensity at P due to charge plus Q. So we already find out electric field due to a point charge. We have E1 is equal to 1 upon 4 by epsilon naught Q upon AP square, where AP is the distance. AP is the distance, that is A to P, that is A plus R. So we can write as R plus A. So E1 is equal to 1 upon 4 by epsilon naught Q upon AP square is equal to 1 upon 4 by epsilon naught Q upon R plus A whole square, and its direction should be along PA. And we also know that electric field directions in the direction electric field direction along PA. And another we have charge plus Q. Electric field intensity at charge plus Q is E2. So we have E2 is equal to 1 upon 4 pi epsilon naught Q upon BP square, where BP is equal to, from figure we have BP is equal to that distance is O. BP is equal to R minus A. Since from O to P that distance is R, and O to B that distance is A, so we have BP is equal to R minus A. So E2 is equal to electric field intensity due to charge plus Q. We have 1 upon 4 pi epsilon naught Q upon BP whole square is equal to 1 upon 4 pi epsilon naught Q upon R minus A whole square. E2 is greater than E1. Why it is greater than E1? Because we know that the electric field intensity formula 1 upon R, E directly proportional to 1 upon R square. So it's mean if the distance is small, then electric field intensity should be very high. So due to plus Q charge is nearer to the point P, then electric field intensity due to plus Q is much higher than electric field intensity due to minus Q. So E2 is greater than E1, and E net is equal to, we find out E net is equal to E2 minus E1, magnitude of E2 minus magnitude of E1. 1 upon 4 pi epsilon naught Q upon R minus A whole square, that is E2, and E2 is electric field intensity at P due to charge plus Q. So minus 1 upon 4 pi epsilon naught Q upon R plus A whole square. Now taking common Q upon 4 pi epsilon naught, and we have 1 upon R minus A whole square minus 1 upon R plus A whole square. Subtracting them, we get R plus A whole square minus R minus A whole square, whole upon R minus A whole square, into r plus a whole square. Since here we have 1 upon a minus 1 upon b, and we take LCM, we get b minus a upon ab. So we have q upon 4 pi epsilon naught. This r plus a whole square minus r minus a whole square, this is a formula. Since we have a plus b whole square is equal to a square plus b square plus 2ab, a minus b whole square is equal to a square plus b square minus 2ab. Subtracting both of them, we get 4ab. So we have 4 into a, that is a, and b is, that is r. So 4ar upon r square minus a square whole square. And in previous lecture we discuss, and we already know what is electric dipole moment. Dipole moment is the effectiveness of dipole. So dipole moment P is equal to Q into 2L. So Q into 2A, here that distance is A, so we have Q into 2A multiply with 2R and 4 pi epsilon naught R square minus A square whole square. Q into 2L is dipole moment, and 2R upon 4 pi epsilon naught R square minus A square whole square. That is the E net. But if the distance A is much less than, or we can say A is very less as compared to the R, or R is very greater as compared to the A, so we neglecting A. So we have P upon 4 pi epsilon naught 2R R square, and this A is neglecting, we get R square whole square, that is equal to 2R upon R ke power 4. So 2p upon 4 pi epsilon naught, and these are cancel out, so we remaining part is r cube. Now we have electric field intensity on the axial line due to a dipole is directly proportional to the 1 upon r cube. Direction of electric field is along BP produced, that is along the direction of P. And another we have this is the another positions we have electric field intensity at equatorial line, or we can say equatorial positions. First we have equatorial positions, means equatorial position is that positions at any point on a dipole is perpendicular bisector, that this is the perpendicular bisector, and we find out electric field intensity at point P. This is equatorial. So we considering an electric dipole consisting of 2-point charges minus q and plus q separated by a small distance, that is 2a. So we simply find out electric field intensity due to plus q, that is this is an isosceles triangle. So we have, this is theta and this is theta, this distance is x, perpendicular distance we take x, and this distance base is x, and this base is a, and this base is a. So we have hypotenuse is x square plus a square, square root of x square plus a square, and this is similarly x square plus a square square root. So electric field intensity at P due to plus q, that is 1 upon 4 pi epsilon naught x square plus a square, and electric field due to minus q, that is equal to 1 upon 4 pi epsilon naught q upon x square plus a square. These two, electric field due to plus q and electric field due to minus q, are equal in magnitude. Now we find out the resultant, and we also know that how we can find out the resultant, where we have various methods to finding resultant. One of them is parallelogram method. So here we have electric field due to minus q and electric field due to plus q. Electric field due to plus q is in this direction, and electric field due to minus q is in this direction. So we find out the resultant. We take here as parallel to AB a line considered here, and this angle is theta, and this angle is theta. So this theta and this is also theta. Why? Because this is an alternate angles. and it's theta, so it should also be theta. So the component of electric field due to minus q is, one component we take is in this directions and one is take in this directions. This component is e cos theta due to minus q, and this component is we take e sin theta. Again we separating the component of due to plus q at point P. One component is in this directions, one component is in this direction due to plus q, and another component we have is in this direction, that is e sin theta. E cos theta due to minus q, e cos theta due to plus q, these, and e sin theta and e sin theta, e sin theta and e sin theta equal and opposite, so these two are cancel out. We have e cos theta and e cos theta, both of them adding, then we get 2 e cos theta. So net electric field at P, E net is equal to 2 e cos theta, 2 e cos theta. So where E is electric field intensity, and we know that electric field intensity 1 upon 4 pi epsilon naught q upon x square plus a square, and this 2 multiplying with E and cos theta. From figure we find out what is the cos theta. Cos theta is equal to base upon hypotenuse. Here we have base is a and hypotenuse is x square plus a square to the power 1 by 2. So E net is equal to 1 upon 4 pi epsilon naught 2q upon x square plus a square into cos theta, and cos theta is equal to base upon hypotenuse. So E net is equal to 1 upon 4 pi epsilon naught p upon x square plus a square to the power 3 by 2. And again we take approximations if x is very large as compared to the a, so we have E net is equal to 1 upon 4 pi epsilon naught p upon r cube. We neglecting the x, so this is the this is expression for electric field intensity on equatorial line of electric dipole. Direction of electric field in equatorial position is opposite to P, so opposite to P means opposite to the dipole. Here we have direction of dipole is in this direction, minus q to plus q. Here we have electric field intensity is in this directions. Thank you.